I'm gonna flip the board. All right, folks. So we're back for myth number 3 about lactate or lactic acid, as some of us might call it, right? So no, right? Always remember we're talking about the same animal. I'm going to talk about the myth and even just some of the ways I'm going to write probably. So lactate is formed because of a lack of oxygen or because of decreased oxygen availability, right? So a lot of times when I write oxygen, you'll see O2, increase, decrease, up or down sign, things like that, because, anyway. So the argument is, the contention is, let's say, that the reason why you're going to have lactate or lactic acid, right, is going to be because either there's a significant, let's say, decrease in oxygen, not just maybe the argument isn't any decrease, right, but it's, let's say, we could look for a marker, right, when you get to X% below what your, for like a homeostatic level is, right, your kind of baseline level is, then we kind of see it, right, or because of a complete lack of it, right. Now, my conditions are almost never be a complete lack of it, right, unless like maybe right before death, but we're looking at kind of normal circumstances, relatively normal circumstances, and people that, let's say, don't have any diseases, no pathologies, things like that, right? I can talk about some examples, and I will, about where these things, right, with certain pathologies and such, that you will see an increase in lactate because of some of these things. But right now we're just talking about, we're just going to say non-pathological populations, right? So the first reason I wanted to talk about it, before I kind of flip the board, right, as I like to say, is I want you to think, one of the ways we'll look at this is, look, first of all, it happens because it's possible, right? It's a chemical reaction, right, that's going to be in an environment, right, that favors it occurring, right? Just kind of thinking about it that way, right? And so if we think about it just kind of through that lens, before we kind of go into all the intricacies of it, right, thermodynamically, if we're thinking about like physical sciences, right, and like, don't be, right, no, this word is really just talking about, right, like the study of energy, heat, chemical reaction, kinetic energy, mechanical, right, just how energies relate to one another, right? And so if you understand it, you're intuitively whether or not you could write the equations for it, right? So just thinking about how reactions occur, right? So we convert pyruvate to lactate. That conversion, that chemical reaction, is exergonic. Now, when I say exergonic, what I mean is that, and we'll talk later about delta G and stuff like that. I don't want to talk about free energy. I don't want to get too sciencey about this just yet, right? But it has a negative free energy, and what we mean is, like, so basically what's going to happen is you're going to break a chemical bond, and you're going to release energy, right? Like that is that kind of chemical reaction, right? It's an exergonic, we call this exergonic reactions, right? So these kind of reactions are what we say they're favored. They can happen with what you'll read, the verbiage, they'll say spontaneously, right? You don't need to add energy for it to happen. So anyway, so it's a favored reaction, right? This reaction, the conversion of pyruvate to lactate, is a favored reaction. Exergonic reaction is a favored reaction. Now, kinetically, like as far as movement, right, and things needing, let's say, to collide and so on and so forth, right? What they call effective collisions. I'll talk about that later, right, within our bodies, so that, right, you have compounds and you have enzymes and cofactors and such, right, and you need them to kind of, right, these things can't see one another. It doesn't say like, oh my gosh, you're a pyruvate over there, I'm a lactate dehydrogenase, I totally want to hang out with you, right? And like that's how we kind of think about it, and I'll use that as a narrative. I like, oh, they like to hang out, they have an affinity for one another, but it's not really that way, right? So they'll if close enough, right, and right, if these kind of active surfaces, let's say, right, get close enough to one another in the right way, right, they'll have these effective collisions, right, they'll come together and you'll have these reactions kind of occur, right? So, but you have to have right, in these environments like this. So you need lactate, you need pyruvate, right? You're going to need some NADH, right? We've already seen you're going to create some of that. You're going to need some free protons. You already saw we're going to create some of that. So we're creating all these things, right? But you still need the enzyme, right, to catalyze that reaction. So, right, in these environments, just so happens, right, whether you believe, it was, created or evolved, right, you have massive amounts of lactate dehydrogenase, right? And so some people will short term that like LD, some people will do it like LDH. That's a little bit older, but anyway, so you know if you see it, right, same animal. Anyway, so there's lots of this enzyme, right? Quick aside, a lot of, how do you know if it's in, this is one of the first day thing you always talk about. A lot of the words you're going to notice that we're going to talk about are going to have this kind of ASE ending on it, right? So for us, right, in biochem, that is like, a blinking light, a flashing light, right? Stop, maybe a red light, right? Stop, right? This is an enzyme, right? Right, and so, what does it do, right? Maybe it removes the hydrogen from a lactate. Now, it does, because it can be used like for pyruvate and lactate. We'll get into that reaction, a whole other thing much later on, but ample lactate dehydrogenase within these fibers so that these reactions can occur, because you have to have that, right? Without that, a collision doesn't matter, right? You can have as much pyruvate and lactate. It can be a favored reaction, but without the catalyst, the odds of it happening are beyond. So anyway, think about that as just like a reason why it's likely to occur. It doesn't have to have even if this was it, you're gonna have, let me be very close, you're gonna have lactate being made by skeletal muscles until the day you die, right? Like when you're at sleep, if you are sleeping and immobilized and the flattest, it's my dog, without movement you could possibly be in your life, right? Like your muscles are going to create lactate for this, just for these reasons right here, right? Just to be clear on that. Right? I'm going to talk about other reasons why and things like that, and I'm going to give you some scientific data, right, to back up the heresy that I am, kind of espousing it, I guess, as it were. But I just want us to kind of think about this as a backdrop, right? So it's not that crazy that it could happen, kind of based on these kind of scientific principles, like these items, right? So anyway, I'm going to assume that is, yeah. Sweet. All right, I'm going to flip the board and I'll be back.